it's Sarakin, and today I wanted to show you guys a way to visualize your indices or indexes on your mesh. So if you've been working with geometry nodes for any period of time, you know that index and kind of especially instantiating things on the index is a really important and kind of base fundamental skill that you need to be able to be fluent or a little bit more fluent in geometry nodes. And one of the biggest issues with that is being able to know what your indexes are at each point in your mesh. So in Blender 4.1, they've added a way to be able to visualize this. And all you have to do is come up here to this viewport overlays, go down to the viewer node section and click on attribute text. And the way this works is that, say you have in this setup, I have a grid here, right? I want to take the output of that mesh and put into a viewer node. So the way you do that, so if I was to get rid of this here, the way you do this is Control Shift click, and then you can add an index node and pop that into value, and then you should see the values again. The reason why this is so important is because you can use the index to determine when and, well, I guess when and where you want your instance thing, whatever you're instancing on your grid or plane or whatever you're instancing. You can use the index to determine where it actually exists. So, a fun thing is that you can also use math. So if I use a math node here, and I come to the, say, truncated modulo, or I guess floor modulo works too. We're gonna come here, and as you can see before, this index goes from 0 to 20, right? There's 21 different points. Or sorry, 0 to 24. There's 25 different points on this grid. Say I want something to exist every, say, 4 points or whatever. I'll put that in here, and so basically what I do is that I say I perform a modulo operator, and we only get a count from 0 to 3, right? So 0, 1, 2, 3. If you don't know what modulo is, it's basically just division, but instead of the actual answer being the output is the remainder. So in this case, I might increase this to 5 so that I get 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, etc., across the entire mesh. So all the indices get renamed. And then I might say something like, you could use this with either a compare or another math node. As you can see, you can add values to it here. But what we're going to be doing is going to say a less than, and we want the less than to be less than 4, right? So as you can see, all the values that are less than 4 are return 1, which is true. All the values that are greater than 4 return 0, or greater than or equal to 4 return 0. So say I want to just, I can put this into a selection, and if I turn off this viewer node, you see how the instances only render on those indexes, the ones where we had 1 come through. So this is one very obvious use case. There are a lot of other use cases for this particular project. Recently, I used it in another more complicated way. Let's see if I can show you here. Maybe we can come to this. So the way I used it was in this recursive subdivision modifier. As you can see here, it's kind of complicated. I'm just gonna do, this is kind of what I was planning for in another video, in fact. But if I perhaps can show you the iterations, how it works. So essentially, I can create more iterations using recursion, and the reason why this works is using the index of each successive rectangle. So, yep, not a whole lot to show there. I just wanted to show you that really quick tip, and hopefully you get a whole lot of use out of it. Thanks for watching the video. Bye.